To find out what electricity is all about, we need first of all to look at a conductor. If we were able to go deep into this conductor and magnify up many times, what you'd find is inside it, the whole thing is built up of atoms. Now if we go and look even closer at just one of these atoms, you'll see that it's made up of a couple of elements. One of them is the nucleus of the atom, and going around it is an electron. The electron has a negative charge to it, a very small negative charge, but nonetheless a negative charge. That negative charge is balanced by a positive one in the nucleus. This is the atom's balanced state, and this is a state it will always be in, and always try to stay in. We can, however, change this by adding a voltage, say from a battery. Now a battery has on one terminal an excess of negative electrons, and on the other terminal an excess of atoms without electrons. As soon as the battery is connected, the electrons on the left here will try and migrate towards the right to fill in the holes on the right hand side of the plate, the place where the positive charge is. Now as you can see, that causes a general migration of electrons from left to right. This is current flow. If we increase the current flow, we could do that by putting a bigger voltage at the end, then it looks like this. So electricity then is simply a flow of electrons from the negative plate of a battery through the conductor to the positive plate of the battery. What we're seeing here is direct current, DC. Now conventionally, DC current flows not from negative to positive, but from positive to negative. And that's simply because when they first started experimenting with electricity, they decided that that's the way it should go, without actually realizing what was happening within the conductor. So most descriptions use what we call conventional current flow, where the current flows from positive to negative, in the opposite direction to the one we've just seen. You could argue that the atoms without electrons have got holes in them, so they're actually flowing from right to left. But nonetheless, the conventional current is from right to left, from positive to negative, electron flow from negative to positive. And for the rest of this program, we'll be using conventional current flow to explain what's going on. Now you may have noticed that we slipped in there the circuit symbol for a battery. Now the circuit symbol itself doesn't have positive or negative signs on it, but if you look at the length of the lines, the positive side of the battery has got the longer line, almost as if you'd taken the positive sign apart and glued it end to end.